Hagrid's dragon is drinking water out of his half-spherical shaped bowl at a rate of 4 centimeters per second. The diameter of the bowl is 30 centimeters. At what rate was the height of the water changing?
That's an easy one, Hermione. The volume's equal to 1/2 times 4/3 pi r cubed. Then you take the derivative, plug it all in, and you get dr divided by dt is equal to negative 0.00283 centimeters per second. Try this one. I travel from the south, and Voldemort travels from the east. We're both trying to get the Horcrux. I start 150 miles away. Voldemort is 75 miles away, and travels at 15 miles per minute. The distance between me and Voldemort is changing at a rate of negative 55 miles per minute. How fast am I traveling?
First, you take the formula a squared plus b squared equals c squared. Then you take the derivative of that formula. So a times dA dt plus b times dB dt equals c times dc dt. Then plug in all the numbers given and find that dA dt is equal to negative 53.99 miles per minute. So you get there first, Harry. Harry must make a potion, but in order for the potion to work correctly, the water must be added to the conical tube at a constant rate. The tube's widest part is at the top and measures 7 inches in diameter, with a height of 10 inches. Before the water is added to the tube, there is a liquid in it that is 5 inches in height.
So I'm trying to find the change in height over time, right? That's another easy one, Hermione. The volume's equal to 1/3 pi r squared h. V is equal to 1/3 pi times 3.5 h divided by 5 squared times h. Then you take the derivative, which is 0.49 pi times 10 squared times dh dt. Therefore, dh dt is equal to 0.00974418.
After this moment, a tragic incident occurred. Harry Potter died because he did not solve the equation quick enough. But if he had used the pain theorem, he might have survived his tragic death. We will now go back in time to Sir Matthias Payne and see exactly what the pain theorem is, so that Harry might survive.
An apple a day keeps the doctor away, but the pain theorem would have kept the doctor away for Harry. As you can see here, all the work is done out, but on the left side, this is the original way for Harry to do the potions problem. And this is the pain theorem. Much quicker, much easier. Over here, as you can see on both, is the volume equation for a cone. And then over here, it's the same on both sides for the height, the diameter, radius, dVdt, which is the change of volume over time, because that was given in the problem. The only difference is the proportion on both of these sides. So in this, you're going to plug in r in terms of h, and then you have to do all that work out. You're going to have to plug the to the power of 2 in, and you have to do all that work. You're going to get this. Then you're going to take dv dt. You have to push the 3 over when you take the derivative, and then you have to plug 10 in, and it's way longer than the pain theorem. But if Harry took the pain theorem, all he had to do was take a real proportion and find exactly what r is in this potion theorem. So, As you can see, you then plug r in, 7 squared, 14, you plug it in, then you take the derivative right away, no crazy math like this. 16.3 repeating times pi times dh dt. You don't have to worry about plugging h back in like we did over here for 10. You can then you plug in change of volume over time in, and you can then do 1.5 divided by 16.3 repeating times pi, and you find this. Then at the end, the secret to the Pain theorem is multiplying that answer times 1 over 3, and that is going to be your change in height over time, which is equal to the exact same thing as you would get regularly.